Hey all you cool sabers, today we are talking about first differences. So the obvious question is, what is a first difference? I'm glad you asked. This is the difference between consecutive y values in a relationship. Okay? The difference, and remember that the word difference in this case, or in any case when we're in math class basically, difference means subtraction. Okay, so the difference or subtraction between consecutive y values. Consecutive meaning one after the other, so the x values would have to be going up by the same amount, or by one specifically. Okay, y values in a relationship. There we go. Okay, so for instance, we're going to take a look at y equals 3x. So the first thing we're going to do is we're going to make ourselves our table of values here. So we did the first couple for you. If we've got y is equal to 3 times x, remember if 3x means 3 times x, so 3 times 0 is 0. 3 times 1 is 3. 3 times 2 would be 6. 3 times 3 is 9, and 3 times 4 is 12. So our first differences means that we're going to subtract. Oh, don't know what just happened. Okay, we're going to subtract. We're going to take this and we're going to subtract that. Okay, so we're going to have 3 minus 0 equals, and so it's going to be 3. All right, then we'll have 6 minus 3, which is equal to also 3. 9 minus 6, which not surprisingly also 3, and 12 minus 9, which is also equal to 3. Okay, so the first differences in this case are all 3. All right, and that is important. If we graph this thing, it's going to look like this. So let's see, on our x-axis, we're going to go, I'm going to zoom in so it's a little neater than, well, except that I don't know how to count. 3, 4, 5, 6. All right, and then on this axis, I'm actually going to go up on a weird scale here. I'm going to go, every other box is a 3. Which works out really well for this one, even though it seems kind of weird. So let's see, so that's our y, and that's our x. So we're just going to plot these points. So we have, let's use blue. We had 0, 0, 1, 3, 2, 6, etc. So we draw a perfectly straight line here, which I'm going to do. Look at that exactly straight line. Not shaky at all. And make sure you label your graph. Remember, anytime you draw an equation, or you draw a line, or anything on a line that you got from an equation, you have to label it with the equation. Those are your communication marks right there. All right? So, is this relation linear or nonlinear? So, the answer is linear, since this is a unit on linear relations. So we know two different ways. So we know obviously that it makes a line. Okay, that's the obvious one that we know. But what we now know that we just learned is that if the first differences are the same, which they were all equal to 3, okay, it's going to be linear. So it's linear because the first differences are the same. Okay. It doesn't matter what those first differences are. They could be -7. They could be 2.2196. But as long as they are all exactly the same, you're gonna have yourself a linear equation. equation. So we're going to try another one here. We're going to do y is equal to x squared, I believe. Yep, y is equal to x squared. So to start with, we have 0 squared is 0, 1 squared is 1, 1 times 1 is 1, 2 times 2 is equal to 4, 3 times 3 is equal to 9, and 4 times 4 is equal to 16. Okay, so we're going to do the exact same thing. We're going to do 1 minus 0, which is going to give us 1. 4 minus 1 is going to give us 3. Now, right off the bat, we know this is not going to be linear because those are not all, first two were different, okay? But we're going to keep going because you never know, you might have made a mistake, okay? And we're going to get 5. Pretty good indication here that, that it's not, and then we've got 7. All right, so this is clearly not linear. We already know, so we can even say, we can even fill out the part C before we even do B. Non-linear. The first differences are different. Okay. There we go. So, they're all different. Now, it doesn't matter that if one of them was different and the rest were the same, technically this would also mean it's not linear. However, it is also a good indication that you probably made a mistake on that one, so I would double check that. But if you're 100% certain, as long as one of them is different, it is not linear, okay? And we're going to graph this just to see what it looks like. I'm going to go 1, 2, 3, 4, 5. That's our x. Okay. And then we'll do our y, and our y I'm going to go up by 2s. So I'm going to go 2, 4, 6. I'm going to zoom in so those are actual numbers instead of scribbles. 10, 12, 14, 16, 18, 20. So we already know this is nonlinear because we already did that. But we want to see what it's going to look like and see if it does, in fact, not look linear. So 0 times 0 was 0, 1 times 1 was 1, 2 times 2 was 4, 3 times 3 was 9, which is right there. 4 times 4 was 16. And we are not going to have room for 5 times 5. Well, we would if we could. Actually, we will. Let's continue it so that we got 22, 24, 26, and then we actually do have room because it's going to be right there. All right. And if we draw a smooth curve through those, you can see that which is y equals x squared, is clearly not linear. Okay? And that's it. So, until next time, go Sabres!